Well, hello, Roy. Good seeing everybody again. My name is George Kilo Foxtrot 5, Quebec Echo Zulu, and I'm the one of the co-owners of the North Texas NVIS Net. I understand a lot of the races divisions and have received packages of the Buddipole system, and I got a feeling you haven't had a whole heck of a lot of instruction about it. So for the next 20 minutes or so, let's talk Buddipole. Okay, I like the buddy pole systems because they are pre-engineered, and we're not talking about an antenna project that you've got off a hobby where you design your own systems and practice your science, and that's good, and everybody loves to do that. But we're talking about reliability on a first antennas back up in the air. We are talking about a system that we have pre-engineered and know it's going to be good. It's going to do what they say it can do. It breaks down into small packages for easy transportation, sets up fast. One person can get it up and operating. It takes up a small footprint. The bands can be changed quickly by just simply moving a tap on the coil. So why are we still so leery about buddy pole? Well, the biggest one is common signal loss. With low signals in, not quite as much power getting out to the other stations. There's four basic conditions that we're going to talk to. Some are related to buddy pole and some are just good old antenna work. The biggest one is ground conductivity. We'll talk radials, reflectors, some counterpoises, and the idea is to eliminate the possibility of losing as much as 50% of your signal strength to ground conductivity. Another one that's important and gets overlooked is impedance. A number of folks that I've talked with go by SWR and that's it. Well, you've got to match the impedance of the antenna to the feed line to the radio, and if you don't, we're talking signal loss. We'll be discussing some chokes and balums and how they can help bring your impedance numbers closer to your system numbers. The antenna figuration and height above ground. I got my own story to tell on this one, and it's another issue that you can use to fine tune the performance of the buddy pole system. And then good old fashioned loss of signal from vegetation and buildings. You need a clear view of the sky. The book says 12 feet, and I think 20 feet's a better idea if if you got the room for it. One of our operators said he had his buddy pole up and checked it twice, and everything was hooked up and in the right places, and he was just having a terrible time. We were having a hard time hearing him. He couldn't hardly hear us at all, and eventually he got to scratching his helmet till the light bulb went back on, and he said, let's go move this thing out a little bit further away from this building. 5-9 reports for the rest of the afternoon. We heard him fine, and he could hear everybody that called. So we'll discuss that. Basically, clear view of the sky. Yes, vegetation will impact your signal strength. The ground losses are the biggest problem and probably the easiest to fix. You can lose as much as 50% of your signal strength with poor ground conductivity under your antenna. If you're on dry ground, rocky ridge tops, even worse yet, asphalt parking lots, these are all poor ground conductors. The solutions are not that terribly complicated for below average ground. You can cure most of your issues with a ground rod drilled or driven down into the moist layer of the soil below you and bonded to your mast. Don't forget to add a radial or a bounding rod to the radial ground terminal. You need 4 to maybe as much as 6 radiating wires, and they need to be clamped to the ground rod in the mast. And they don't. The nice part is they don't have to be particularly long. Most of these buddy pole systems only extend out 9, 10 feet, 15 feet, so you don't need real long wires. You probably ought to take into mind trip hazards. So mark them with a traffic cone or something, but they're in contact with the ground. Now, if you're going to do a reflector under your radiating wire, remember the old standby, 5% longer than radiating element and run parallel. About 0.02 to 0.06 wavelengths below the radiating element. That's 6, maybe 8 feet. Keep it at least 2 feet above the ground. And these work pretty good off the inverted V's. Now this disclaimer, the soil or the picture you're looking at is of a nice green lawn with lots of moisture planted on top of a loam fill. You're not going to get better ground conditions than that. But for the picture, but for the purpose of taking a picture for the class, I went ahead and used my backyard. If it's dry and rocky, you really need to consider it. Now, we're talking average ground conditions. What about very bad ground? Real dry, real rocky, desert stuff. You're going to probably have to switch to a counterpoise type of wire. These are geometric patterns. They're situated above the ground and supported on insulated stakes. Ideally, they should be a little larger than the antenna system. And I worked with an outfit in California that used traffic cones. They just made a slit in the top of the traffic cone, and they put their cones at each one of these points. It helped hold it up off the ground, and it made a physical barrier where you could see where the wires were, and people wouldn't walk into them and take them. This is a little more work if you've got a semi-permanent station that's going to be out in the field and you need to get a good system going. This is worth the time. If you're mobile or portable and things are real dynamic out there, this is probably not going to work out. You're better off just going with a stake in the ground and some radials. Let's talk the chokes and the ballums. The choke ballum that comes issued with the Buddipole system is it's good down to about 7 megahertz. Some will say 8, depending on their station location, I guess. Know that the Buddipole systems are off-center fed dipoles. They're designed and all their charts are based on an antenna height of 9 feet with 25 feet of coax. Now, clearly, if you've got 50 feet of coax or you're using a different height, this is the numbers on the charts that come with the product are probably going to need a little tweaking. Get your analyzers out. But this isn't the most efficient choke ballum for deal. It does have an a built-in adapter for the banana plugs into the Versity receptors. So it's quick and it's easy, but it's not the most efficient. If I had to make a recommendation, I would recommend the Buddipole TRSB, which stands for Triple Ratio Switching Ballum. It's the 2 model, Buddipole TRSB2. And this is another device that is well worth the upgrade. If you need to get into the lower end of 40, 60 meters, 80 meters, you're going to need this ballum on your system to replace the choke ballum. Now, the beauty of this is we're not talking a straight half-wave dipole. All the whip lengths are equal in length. You don't have the standard off-center fed dipole where one is 10 feet and the other one's 15 feet. So all the whips will be fully extended and they are equal in length. So there's no measurement. If you want to switch frequencies, you simply move one of these banana plugs into a different position. The impedance match that we talked about earlier, 3 separate impedance positions. You know that the Buddipole antenna at 10 feet is going to have a low impedance ohmage, and you're going to need a way to adjust that up so you can match your 50 ohm impedance of the system and your coax. You don't want to lose that power, and this is the way, the quickest and easiest way to do it. There's more of a reverse voltage isolation. There is an issue with power rating. I would ease into that. I wouldn't go full power out. I would keep it down around 250, which is where I was. And for 300 miles, that's more than enough power. The book says one place, no more than 100 watts. the manufacturers reps that I talked to said they ran them on CW for half a day, and the balun didn't even get warm. So I'm not sure where this conflict is. Just keep an eye on your balance. Of the antenna height, setting up the antenna system. The system is assembled at eye level. These are all telescopic masts. It comes with an 18-foot telescopic mast, which is really handy. I like that whole setup a lot. A built-in tripod. Set it up at eye level. Remember that when you hoist your antenna aloft, which is usually in the neighborhood of from 9 to 16 feet, your resonant frequency is going to go up as well. When you lower the antenna, you can get less noise. The resonant frequency will go down, and fortunately, so will your power and your signal strength. So, depending antenna height makes a big difference on both power and noise and resonant frequency. If you'll notice this particular antenna or analyzer, I set it all up. I had 50 ohms right on the button. I had 1.2-ish SWR. I was tickled. And I hoisted it aloft, and look what happened over here. 7355. This antenna was set up at the ground level of 7255, and when I sent it aloft, the frequency went up with it. Antenna height is going to be a fine part of your fine tuning of the antenna. So kind of set your resonant frequency at eye level a little lower than you want to actually operate on. Now let's improve the standard components. There's long whips out there that have, because of their length, they don't need as much coil in your loading coils, so there's less inductance. These things are 9.5 feet long versus the 66 inches requires less inductance to resonate the antenna, hence less signal loss. Make sure when you use your charts on these new whips, they're not new, but on these whips, that you use the form 350, and I'll show you exactly how to get to that form, operator's manual form, starting with 350. The charts are designed for standard whips versus the long whips, TRSB balums versus the choke balum, and they'll give you a good reference point. I swear by the long whips, and this particular system that you're looking at, I did the November on-air net. Talked to people locally. I talked to people in Albuquerque, New Mexico. In Amarillo, Texas, and they all had good reports on my signal quality, and I was running for a good part of it 65 watts. So the long whips are well worth considering with your TRSB balum, adjustable balum, and I think you'll find this is a very, very doable system. Okay, the standard coil and the long whips. Let's show a little more about these charts that I've been talking about. If you'll notice on the 40-meter band, we have a triple ratio switching balum setting of 4:1. The red tap is on tap 25 in the picture. The whips are fully extended. Black tap, 25. Whips are fully extended. The antenna height was 11 feet. When I put this thing up for the very first time, I stuck in all these features and put it aloft, and I got an exact 50 ohm match and a 1.12 to SWR. Now, 30 meters, it doesn't take any more than moving the red banana plug to the next spot, and it's all pre-set up 4:1. All I had to do is change the tap position, fully extended lengths, so on and so forth, 11 foot of elevation, and I got pretty good signal reports. Now you say, what the heck are we going to do on 30 meters? Well, to start with, the space weather contingency planning that you do, part of it is just move up in frequency. And some of that 40-meter noise is going to be not near as bad on 30 meters. It's worth a try. Nextly, relative to space weather contingency planning, you want to know what your space weather is. And if you go to 10 megahertz and turn and listen in, you'll be hearing the time clock 18 minutes past the hour, and you're going to get your solar flux indices and any special weather statements that NOAA puts out about space weather. So you'll get an idea of what you're dealing with so that you can make a plan, especially if you're looking at multi-operational periods. So 30 meters, 10 megahertz, everything was fine. All I had to do was move the tap position. Now, 20 meters, this one didn't go quite as different. Had to switch the TRSB to 2 to 1. The tap position was now only 7. Now, let me clarify. When you measure the tap count, the tap wraps on these coils, remember, this is the whip that screws into one end. This end goes into the fixed rod that comes out of the Versatee. This is fixed, and this is your coil. So if you want to just use a little bit of coil, and then you're going to use this one here on tap 7, and you can literally count them 1, 2, 3, 4, 5, 6, 7, and hook it up. They're easy to move around. So I went ahead and did that, moved my plug to my plug Buddipole to here. That shorts out all this, and this is all the coil we're using with the long whip. Now, the problem is that this particular band worked the best if the whips were down to 107 inches. And you can trick yourself into looking at it. You measure it out all collapsed that are 22 inches long. And I figured, well, there's 6 segments, 22 inches. Okay, that's 132 inches. Get it down to 107. I have to take away X number of inches. Well, the truth of the matter is every one of those whip segments are overlapped inside for strength. And this whole thing, fully extended, is only 114 inches, which means all I had to do to get to 107 was retract that last whip in 7 inches. So it took me a couple of tries before I figured that out. The easiest way to do it is just extend that whip all the way out on the floor of your home or your yard, put your tape measure right next to it, and get your paint pen out and mark it at 107. Now, next time you got to go down to 20 meters, slide it down to the paint mark, and you're off to the races. So I did all this. I was tickled to death. I figured it out, got it up in the air. It was terrible. So I said, well, darn it. So I literally played with this for about an hour trying to get a decent analyzer reading. And eventually the light bulb went on. Antenna height. So I took my 11-foot antenna and I moved it down to 10 feet. And it was a little better, but it wasn't acceptable. Down to 9 feet, and eventually down to 8 feet 10 inches. And I got 50 ohms with an SWR reading of 1.2 to 1. The resonant frequency was in fact 14.6, which I was hoping to get it a little bit lower, but it was close enough that the auto tuner on the radio could make up the difference. 8 measures, lay them out, take your paint pens and mark your whips just like we've marked the coils here. You see paint marks on the coil, red, green, and yellow. And basically this makes all the transitions real smooth and simple. Right now, one of the other things that the new manual, Operator's Manual Form 350, did that the others have not done was they included a section on Buddipole maintenance, which I was real appreciative of. Well, before we get into that, wind damage. If any of you have had any experience with wind causing these whips to bend, I'd like to know about it. I haven't been able to find anything in writing about winds causing these whips. I think common sense will tell you if it starts getting too cold or windy and they start moving around too much, bring them back. Wait till the wind stops blowing and put them back up. But if anybody's had knows a specific velocity of wind that caused a specific amount of damage, I'd really like to know about it for our reports here. Now, the one that I found was the banana plug bar right in here that gets loose. Those little inserts have a tendency to get pushed together, and the banana plug itself gets loose in the socket. You can have nice SWR and then look over, the wind blew a little bit, and darn nation, the just went off the chart. That's most probably a banana plug that is loose in the socket. I just looked all over the place, couldn't find anybody that talked about maintenance on a banana plug until these guys put their new form out. And the truth of the matter is, it's nothing more than taking a jeweler's screwdriver, slip it between the insert, the parts of the plug itself, and give it just a little bit of a twist, just enough to move it. Do all three segments and try it back in your receptacle, and I think you'll find a nice tight fitting. You're going to have to do this periodically. They are prone to getting loose. About the only thing else that really needs to be done is Permatex the old threads. Give them a little bit of thread lubricant, and when you go to put it together, dielectric type of lubricant. Permatex 22580, I guess, is one I use. Just a dielectric lubricant on the threads so that they don't get hard to move around and end up bending them trying to get them apart. Your whips. Periodically take them out, especially if they've been out in the weather. Take them out, open them up fully extended, wipe them off, get them clean from dirt and dust, and let them dry. And then fold them all back up, put them away for next deployment. Hand tight only, guys. Don't wrench on these things. Just make them meet. And that means in the morning you're going to have to go out and check, hot days, cold nights, and you're going to probably find that some of this aluminum is going to move around a little bit. Check your connections, make sure that they're all nice and tight. Okay, let's talk the inverted V for a few minutes here. They make a adapter that screws on the end of the coil, and right on the very end of that coil, and you extend out a piece of wire, and you can make it into an inverted V without having to deal with the whips. If you have to get into your 60 meters and your 80 meters, this is the easiest and simplest way to get into those lower bands. On the 80 meter band, your wire length has to be 28 feet. There are no tap positions, and the wire length is 29 feet. On the black side, again, no tap position. So you're using all the coil, and all the wire in your on your winder has to be out. But it only takes a small amount of space compared to the others, and you can get it at a reasonable height. This antenna in this picture is the 60 meter antenna. I had, in fact, 12 feet of wire out. I used tap 37 on the red side, 15 feet of wire on the black side with no taps. And it's now up center fed dipole again, but it is quick, it's efficient, it allows you the continuity and the convenience of being able to switch bands to pretty much anything you need to do with one antenna system. That may be all that's left, or the rest of the stuff may be all down and broken up. So it's a good deal. If you have to get into 40 meters with this system, it's 14 feet, tap 16, 17 and a half feet, tap 20. Good place to start. These flat top antennas are going to be more efficient than the V's. The V's are prone to create a little bit of a skip, and it means you might lose some of your local contacts. But for the most part, this is your most versatile setup, and I think you'll be happy to know you've got that option. Again, this is some of the... We talked about the wire adapters, and here's a little closer view of it. The wire adapter is a simple 3/8 24 thread, maybe a 1-inch bolt. You can make it yourself, or you can buy the adapter from Buddipole. It has a cute little handle on it, and makes it easier to in and off without having to run for tools. And this nut will clamp down on your crimp-on connector ring to your wire, and basically it's that quick. You spin that thing, the whips off, you spin the adapter on, hook your wire up to it, snug it down with this clip, hand tight only, and run your wire out from a wire winder to a stake. Now again, you want to keep it a couple feet off the ground. I try to keep the if you have the options for post on the ends of your wires, then I like to keep the inverted V's as flat as possible. But if you just run that wire out to a wooden stake in the ground that's 2 feet off the ground, I think you'll find that these things work good. That 60-meter antenna I showed you in the last slide talked from Southwest Fort Worth to Albuquerque, New Mexico, with a 5.7 report and a clear audio. Now, to make it all simple, this wire winder, if you make it 32 feet long and wrap it around one of those plastic winders with a slot in it to tie everything off, you can use this same wire for all 3 bands. They're all different lengths, and all you got to do is take that paint pen and go ahead and make a mark. And here's the mark for 40 meters, here's the mark for 60 meters, here's the mark for 80 meters, and you got it all on one wire winder that you can fit in the palm of your hand, and it gives you more versatility with your deal. You can get these paint pens in just about any craft store, and I think even Walmart's got some, depending on how many colors you want. Now, I promised you to get some references and links to various different stuff. If you go to our Groups I.O. page, North Texas NVIS Net, the full link is up above on right there. The wiki folder. Now you got to join to get to these folders. So if you're not a member or haven't signed up, request to join, do that, and then you'll have access to the wiki folder. In that folder is going to be the Buddipole NVIS guide, its basic theory and operations of NVIS, really short, concise, good charts, 12 or so pages, and it'll also describe the various different components that make up the NVIS system. Below that is the Buddipole Quick Fix. It's for the inverted V's. We just talked about a few minutes ago for the inverted V conversion for 40, 60, and 80 meters using the standard coils. And below that, if you're into the heavier stuff, Buddipole in the Field by Scott Anderson, 170 pages, very technical. It's pretty wordy, but it's got some interesting stuff in it. Now, above the wiki folder is the files folder and the Buddipole Ops Manual that I talked about. Now, this is the new release, Form 350, and it's I don't even think it's on their website, but regardless, he gave it to me just to get me off the phone, and I'm giving it to anybody that needs it. These are the current charts that have got the most information in it, including the technical and the maintenance. So go ahead and get that. Below the Buddipole manual is the field notebook. It's the full-size version, 8.5 by 11. When you can't get your computers to hook up to the internet, this is going to be your base references that you'll need to get things started in the field. Below that is a field notebook. It's the pocket size. Excuse me, the pocket size 4x6 inch version, little because it's smaller, not quite as much info in it, but the critical stuff you need to get things started in the field. Now, there's a new white papers folder. There is in that folder, click on the white papers and it'll take you to the link to the weak signal communications using the digital software JS8 call. Now, this is a project that we started up when we said we needed an option for space weather contingency planning, one of which is digital. A couple of our guys, 3 or 4 of them, actually got together and they researched and tested and documented and went through a phenomenal amount of work to get this white paper produced on how to use the JS8 call and make it serviceable. Now we're going to spend a little bit more time figuring out ways to make that fit into our comm plans. But it's when 40 meters just is totaled out and voice isn't doing it, you still can work with JS8 call. Excellent white paper. Again, it's, I forget how many pages, 15 pages or so, and very concise, very well written, good document. So check that out. And below that is going to be a video folder which will have this very presentation in it if you want to reference this presentation again yourself. And the last subject is practice. Practice, practice, practice. Now, one of the primary original purposes of the North Texas NVIS Net was to have on-air training for people that have got their systems assembled and want to try them out, see what kind of coverage they're getting, get some signal reports. We have on-air practice. It goes off the first Sunday and the third Saturday, 1400 hours Central Time on 7.252 megahertz. If frequency is busy, look for us down 10, and we should be there. If you have questions about your system, this net is designed to give you access to all the people that have had luck with the Buddipole systems, and they're going to go ahead and be happy to answer your questions if you post them on the group's IO. And if you've got other issues you want to talk about, my email address is right there, grobford90@gmail.com, and I'll be happy to work with you. Gentlemen, it's been a pleasure. I wish you all luck and looking forward to hearing you on the on-air nets.